Hello everyone and welcome to this video demo for our final year project on dense captioning of images. So let me talk a little bit about the project first and then we'll proceed to the video demo. So the group members involved are Jaising Rajpar, Deep Shah and Arshil Patel, which is me. So we are the group C34 and we are working under our guide Ms. Poonam Bhogle. Talking about dense captioning of images. First of all, the reason for choosing this topic was it's easy for us as human beings to just have a glance at a picture and describe it with an appropriate language. But can you write a computer program that takes images as an input and produces a relevant caption as output? So the dense image captioning task describes the object within an image by identifying them and their surroundings. And what it does next is it establishes a relationship between them. It does not just generate a caption. It gives us an entire summary of what all things are a part of the image and how they are interrelated. So we did this with the help of deep learning methods and neural networks such as CNN and RNN. The captions generated are not a single sentence but a group of them which give a detailed description of the image. This topic has a very vast scope and it has applications in many fields such as CCTVs, aid to the blind, aid to the colorblind, Google image search, and text to voice. So now talking about the prototype, after conducting research, brainstorming, and reading a couple of literary reviews, we decided to use Flickr 8K dataset. It was imported from Kaggle, so there are 5 captions already present with each image. And we used the Inception V3 model and CNN RNN in an encoder decoder format for the generation of captions, and then performed training of the model and further evaluation. We used the beam search algorithm and we evaluated our model with the help of BLU score. So the prototype front end and back end, it was built and developed using various technologies, tools, and concepts, which are listed over here, which include Python, TensorFlow, Keras, Pickle, Flask, VS Code, and Google Colab. So the testing was performed on the website and it was successfully implemented and deployed. Now finally coming to the video demo of the prototype. But everyone, so what you can see over here is we have opened our code in VSC. So what I've done over here is, as you can see over here, there is the index.html file. We have kept things very simple. When it comes to the UI, we have just kept 2 buttons, that are the browse button and the submit button. So there is no such process such as login or anything like that. And now coming to the app.py file, where we have imported Flask and we have used that so that the user can upload an image and the caption specific to that image can be generated. And over here in the caption.py file, we have imported various kinds of libraries. We learned about all of these concepts and then went ahead with further implementation. As you can see, we have 2 models over here, Inception model and Caption model. We have used Pickle for importing the model weights that are there. The max length of any caption is 34, the vocabulary size is 1652, and the embedding dimension is 200. So we have done pre-processing, then we have done encoding, and then we finally implement the beam search prediction. This part has been explained in very much depth as a part of the intermediate steps, which will be shown in the live demo. So based on that, we get the final caption. So what I've done here is I've already kept the terminal open. So I just have to implement Python app.py, and then you can see that an address will be generated. So we just have to copy this particular address and then we have to paste it in the Google Chrome browser. So I just go over there and I just paste this, and you can see that the website will be deployed. It will take a little bit of time to load because we have an i3 laptop. So uh, we just select the type of image that we want to upload. Now, what I'm going to show you is our website is capable of generating captions for various kinds of images. There is JPG, there is JPEG, there is PNG, and there is also black and white images and various kind of images like that. So first, I'm going to select a JPG image. So you can see the UI is pretty much simple. Image captioning, uploading an image to generate a caption. So there is the choose file button, there is submit button. So I've chosen the file, I click on submit, and it will take a little bit of time to load. Okay, so you can see that the caption was generated for PNG kind of file. The generated captions fisherman fishes in a foggy field. So that is a somewhat relevant caption. Now we will repeat the process for a different kind of file. We have done JPG file. So now let me go ahead and select a PNG file. Now this is a PNG file. I open it and I click on submit. So now it's loading again. Okay, so for PNG file, the caption generated for this image is group of people are standing in front of a statue of water. Okay, I guess the end part is not that relevant, but we can see that a group of people are standing over here. Now let us try with a black and white picture. So I select the black and white picture and I click on submit again. Now it's loading. Okay, so for the black and white picture, we can see that the caption generated is group of people are standing in front of an outdoor scene. So that is perfectly relevant. So I guess that explains that our website, our prototype is capable of generating captions for any kind of file that is present. So that concludes our video demonstration. Thank you for joining.